many chemical reactions are reversible. So the definition of a chemical change is one in which at least one new substance is formed. And you might have been taught lower down the year groups that chemical change is something which is difficult to reverse. That's not true. So chemical reactions are often reversible, some of them to a greater extent than others. And two of those are listed on your IGCSE specification. We're going to have a look at what happens with those today. So the first one I'm going to show you involves ammonium chloride. This stuff here, and ammonium chloride, if I just hold that in front of a dark background, you might be able to see is a white solid. So ammonium chloride, a white solid like that. So I'm going to put some ammonium chloride into a test tube like so. So I'm just going to take the lid off and grab a spatula and just take maybe a couple of spatula loads of ammonium chloride into the test tube like that. So ammonium chloride then, formula is NH4Cl, and that's a white solid at room temperature. And what I'm going to do is heat that up. So if I heat that up, I'm just going to take the test tube and pop the test tube holder on like so. Notice that I'm keeping my hand away from where that test tube goes, so that if something spits out and is hot, it's away from my hand. I'm going to hold that in the flame in a moment. I've just checked that the windows are nicely open, because if I heat this too strongly and things come out at the end of the test tube, those gases that are produced are not particularly pleasant to inhale, so just having that window open helps to reduce the risk. So let's turn to a blue Bunsen flame, and I'm just going to heat this up. So I'm just going to pop that into the flame like so and heat it up. And it only takes a few seconds for me to heat this up, and then I can stop. So I'm just going to heat it again. I can see it's starting to work, but I'd quite like to give you a more convincing opportunity to see what's happening in this test tube. So heat it nicely in that flame like so, and I'm going to stop heating it now. So what you might be able to see in that test tube, if I turn that around like so, is hopefully, and again a slightly darker background might be helpful, hopefully you can see that something is changing towards the top of the test tube. And what we've got here then is some of the unreacted ammonium chloride. Then there's often a little bit of a gap, and then a white solid starts to form up here. So what's going on? Well, first of all, remember where the heat source was, right at this end, where the test tube is really hot. And the further up this test tube I go, the cooler it gets, to the extent where actually I could touch it up here with absolutely no problem. That's not hot to the touch in the slightest. If I was to put my finger on here, I would burn it quite nastily, because I can feel the heat radiating off. So to explain these observations, it's important first of all that you recognise it's hot down here, and the further up the test tube this is going, the cooler the test tube is getting. And what you can see here is evidence of a reversible reaction. I heated the ammonium chloride down here, and it broke up into two different colourless gases. When those two colourless gases collide together, like they have done here, as long as it's cool enough, so not down here where it's too hot, as long as it's cool enough, those two gases can react together again to form ammonium chloride. So the white solid here is actually the same stuff as down here, but notice the gap. So this breaks up, those gases start to diffuse away up towards this end of the test tube where it's much cooler, and as soon as those gases collide together and the temperature is low enough, they will form that white solid again. Let's write a couple of equations for that then. I'll just set that into the test tube right like so. So NH4Cl heated up produces two gases, ammonia gas, NH3 gas, and the second gas, HCl gas. But to allow those two gases to react together at room temperature, and those two gases, NH3 gas plus HCl gas, will react to produce, again, that NH4Cl, which is a solid. So this is an example of a reversible reaction. This stuff heated up breaks up into two gases, but those two gases can react back together to make the ammonium chloride, as long as the temperatures are correct. A second example of a reversible reaction that's covered in your specification involves this stuff here, copper-2 sulfate. Now, copper-2 sulfate you've met before, and in fact you've met this reaction before, but it's worthwhile just revisiting this in this context as well. So here I've got some copper 2 sulfate crystals, albeit they're small crystals. I know that they're crystals because they look a little bit shiny. If I look at the bottle, it sort of glimmers a little bit, so they look shiny, which suggests it's crystals. But also the thing that tells me that this is copper sulfate crystals is that they are blue. So in this test tube, it's that copper sulfate, CuSO4, with 5 waters of crystallization attached to that structure. So remember, this dot 5H2O means that there are 5 waters of crystallization for every 1 entity of CuSO4 within this structure. So this is the hydrated copper 2 sulfate, and it's blue crystals. So you've met these before. Now, in the previous topic, we met the idea that we can heat these things up and remove the water. So I'm going to take this test tube and I'm going to just pop the Bunsen burner onto the blue flame and heat it reasonably strongly in an attempt to remove water of crystallization from these copper 2 sulfate crystals. So I don't want to heat it so strongly that we get some breakdown, but perhaps you can start to see that when I heat that up reasonably strongly, that blue crystal structure changes, and what we end up with is a white powder like so. So we've got a white powder being produced. And actually up towards the neck of the tube here, I've got a colourless liquid which is condensing in the region of the tube where it's a little bit cooler. So in the region of the tube where it's a bit cooler, the water's condensing, you can perhaps see some steam coming out the top of it. So that is one way for that reaction. And if I very carefully and at arm's length, in case this goes a little bit dodgy because of the test tube potentially cracking, if I just turn this back down like so, what you might be able to see is that it goes back to blue and that white powder comes into contact with that colourless liquid. So there's some evidence that removing that colourless substance which condenses up here as a liquid turns the blue crystals into a white powder. Reintroducing that colourless liquid turns that white powder back to being blue. And this is another example of a reversible reaction. I'll just set that in there to cool down. So CuSO4 with 5 waters of crystallization, if we heat that up, as I did in the test tube, we get CuSO4, which is a white solid, and those 5 waters of crystallization get driven off. I've put that as a liquid. In actual fact, it will be a gas, which then condenses to a liquid at the top of the tube. But then if we take those 5 waters, I'll just clear off this here now. If we then take 5 waters, 5H2O liquid, and add them to that anhydrous white powder as a solid, then that makes this stuff again, CuSO4 dot 5H2O solid. So heating this substance up breaks it down into CuSO4 with its 5 waters. This is a reversible change because we add 5 waters to the CuSO4, which is anhydrous, to make that hydrated copper sulfate again. So there's a second example of a reversible change that you need to study at GCSE.